Hi, everyone. I'm Omer Basith. I am the CEO of Virtual Forest, and I'm really happy to be here.
There was a time when the world thought that poverty reduction would only happen through government intervention. But we have now seen how the free market system lifts up the wealth levels of entire nations and builds a robust middle class. Similarly, it is the work of innovative startups more than government intervention that is actually making an impact at scale in the fight to reduce our collective carbon footprint. In this episode, your host Akshay Dutt talks with Omer Basith, the founder of Virtual Forest, which is a startup helping appliances companies to build more energy efficient products. Omer has had a fascinating journey from first running a family business to now building a funded technology design startup. In this conversation, he talks about the impact that is possibly just by adopting superior motor technology in products like air conditioners, fans, washing machines, and electric vehicles. Stay tuned for the conversation and subscribe to the Founder Thesis podcast on any audio streaming app to learn about how startups are helping save the environment while building a sustainable business.
I'm from Bangalore. My grandfather started life as a goat herder, I'm told. Like, started life buying goats somewhere outside Bangalore and then herding them and bringing them to Bangalore and selling them at a higher price. He somehow learned how to make ink and also managed to get a contract to supply ink to the government during World War II. And in a lifetime, he went on to set up what was a huge soap making factory in Bangalore called Desi Soap Works that made sandalwood soap. And from what I'm told, was extremely successful and wealthy, and also in a lifetime lost it all. Yeah, so apparently there was a ban on something called tallow, which is one of the main things that they use to make soap. And
That's like animal fat tallow.
yeah, animal fat. Yeah. So that meant that his business fell apart. So my father borrowed a little bit of money from my grandfather. I think he made him sell his car, and this was when they had nothing, to start a electronics company. They set up a company to start supplying capacitors to ITI, Indian Telephone Industry. So they set up a company. My mother and my father set up a company, and they started doing business with a government entity. And unfortunately, when I was 6, my father passed away. And so then my mother was forced to take over the company and run it. And as you can imagine, I'm talking about 1986. It was very difficult for a woman to run an electronics company. And at its peak, it was employing 350 plus and stuff like that. And my uncle and my mother ran this company for many years. And then after that, I came and joined this company for a couple of years, and I left and did my own thing. I've worked in every single domain that you can think of. I've worked in hospitality, I've worked in media, I've worked in logistics, and then a couple of different industries like that. But eventually, after working a few years in that company, I went and did my own thing for several years, and then came back, worked for a few more years, and then sold that company. I exited that company, I'm going to say about 5 years ago now.
Did you get like a reasonable amount of cash on selling it, or was it just sold for parts?
I sold for parts.
Okay. So then tell me that decision-making process of deciding what you want to do next.
When all of this was happening, I just had children. My children were very young at the time. And it became clear to me that with the finite amount of time that I have left in my career and possibly on this earth, I wanted to do something that would be a little bit more relevant and certainly would be able to do something towards combating climate change. I personally believe that's the priority for certainly my lifetime and possibly the next century. So there was an opportunity here to go after the application that I knew very intimately. That was motor run applications. Motors consume about 65% of residential energy in your typical home. That's with your fans, AC, refrigerator, washing machine, and whatever other application that you might have. The technology which I was working on was for induction motors. These motors typically are 65 to 70% efficiency, and absolutely high efficiency motors are a little bit higher than that. The newer technology, which is BLDC and other motor types like PMSM, are 80% plus. So by shifting over to these motors, you're seeing a certain efficiency improvement, and this consequently leads to more energy efficiency. But apart from that, these motors also can be controlled with high resolution speed control. So you can speed up and slow down or do whatever you want with these motors, where you would need a gearbox otherwise to change the speed of an induction motor. So that's the technology that I started working on. This is a domain called motor control.
I want to zoom in on this induction versus BLDC. What is an induction motor and how is BLDC different at a fundamental level?
Induction motor technology is something that's been in place for over 100 years and maybe even more than that. I'm not entirely sure. And this is a robust design that's easy to control and doesn't need specialist electronics. It can be started on control using electromechanical control. So induction motor is a stator with copper windings that operate as a rotor and that causes the motor to move.
So like electricity does some magnetization which causes the circular motion.
Yeah. So the current passes through the copper windings, which causes a magnetic flux, which makes the rotor move around.
And why is it only 60% efficient? Where is the remaining 40% going? That's like heat waste or something like that? Or?
Yeah. Induction motors are prone to heat up. There is certainly loss of power for heat, loss of power for sound, then the noisier than BLDC motors as well.
Okay, so that's induction. Got it. Okay. Now, what is BLDC?
BLDC stands for brushless DC motors. Okay, so these are permanent magnet motors. So the magnetic flux is created using a permanent magnet. These are more efficient, less noisy, less prone to heat, and also have a longer life because of less wear and tear.
Why is it called brushless? What is the significance of the word brush here?
So DC motors otherwise use a brush to connect the rotor to the stator, whereas in this case, that is not the case.
So induction is AC and BLDC is DC.
In a manner of speaking, a three-phase induction motor also operates in a similar sort of method to a BLDC motor, and the same sort of motor control electronics can be used for a three-phase induction motor and a BLDC motor as well.
In a BLDC, there is no loss due to heating and sound and all that?
There is, but less. No machine is perfect. So there will be losses for the same reasons, but less, considerably less compared to an induction motor. Induction motors have a very, very high starting current. To get an induction motor to start rotating, it requires sometimes twice as much of its normal operating current. And that's, again, a huge challenge because that puts a lot of strain, a lot of starting inductive load on the grid. And imagine everyone started there.
Okay, but in case of BLDC, because it's permanently magnetized, it's using some permanent magnet, so therefore it doesn't need so much starting.
Yeah, it doesn't. It's a gradual starting cycle, and again, it's controlled by electronics, by motor controllers. So you can have a sort of what's called a soft start or a gradual ramp up, rather than what happens in the case of an induction motor. The other thing is that an induction motor runs at one speed. It turns on, it runs at full speed. It turns on and you turn off and it stops. And these are the only two operating modes.
And to change the speed, you need gears. That's the only way to change the speed.
You need gears. There are also methods to change the speed using voltage, but then that makes the motor considerably more inefficient. So that's what happens in the case of your ceiling fan with your wall regulator. You're changing the fan speed by reducing the voltage which reaches the motor. However, at lower speeds, the fan is extremely inefficient.
And this voltage regulation is where a capacitor comes in?
Yeah, in the case of a wall regulator, yes, it is capacitors that are used to do this.
Because I remember as a kid, when the fan would slow down, the electrician would say, capacitor kharab ho gaya hai, badal raha hai.
But that's not for the voltage regulation. So that's a motor run capacitor. I'll try to explain what happens there. So now when you're using AC current, when the current is in the positive cycle, the motor runs 50% of the overall 180 degrees. However, when it goes into the negative cycle, the capacitor discharges into the winding, hence giving it enough power to complete the rotation. So that's what a run capacitor does. That, incidentally, is the type of capacitor that my older company used to produce.
But in case of a BLDC, you're saying that you can change the speed of the motor without that wastefulness which is caused by voltage control.
Absolutely, yeah. So that's how it is in the case of BLDC. But the challenge with BLDC is you require motor control electronics, which add cost to the overall product, but overall really improves the functionality. You can have very high resolution speed control, like just 1 or 2 RPM even. And now you can use this functionality to help save energy as well. So motors follow something called the affinity laws. So the affinity laws define the relationship between motor speed and power consumed. So there's a cubic relation. Say a 10% speed reduction in the motor can be a 35% power reduction in the motor. So this is why it's important to be able to control the speed. Now, in the case of a normal, let's talk about air conditioning. In the case of a normal air conditioner, you switch on a fixed speed air conditioner, you turn on your air conditioner, it runs at full speed. When it thinks it's reached a temperature, it cuts off. And then it starts again after the temperature increases by whatever threshold that's required. Whereas in the case of an inverter air conditioner, it gradually speeds up, reaches the temperature you want to reach, and then it slows down slightly without going off. And the temperature is then modulated very effectively to make sure that you're using as little energy as possible. So the combination of the more efficient BLDC motor along with the speed control algorithms that are in place in these appliances, in the case of air conditioning, mean as much as 30 to 35% energy saving when compared to a normal air conditioner.
You don't have that cold start energy loss which would happen in an induction motor.
You don't have that starting load, plus also the speed control that's in place helps reduce the overall energy consumption as well. So there's a very real energy saving that's happening over here. And in the case of an application like ceiling fans, there's literally a 50% energy saving between a normal ceiling fan and a BLDC ceiling fan. And that's very significant. That's a real focus area for us.
Like the energy rating. So if an AC has a high star rating, that probably means that it's because of the BLDC motor, or that could be a major contributor.
Oh, yeah. So look, India's been on its energy efficiency journey now specifically for air conditioning from, I'm going to say 2011, maybe. And really the standard and labeling program, that's the B star rating methodology, is possibly the world's largest energy efficiency program, and certainly one of the most effective. The way it works is, this is something that most consumers aren't aware of, and rightly so, is that the star rating system for air conditioners, when it was defined, a 5-star rated air conditioner at that time can no longer be sold in India. So every 2 years, the star rating system is revised. So a 5-star rated unit right now in 2 years' time becomes 4-star, and so on and so forth. We're constantly on this journey to be more and more efficient. And it's interesting that this is not something that the end consumer is particularly concerned about, because they're not going to, and they shouldn't be liable to pay more for an appliance saying that, okay, the star rating is revised. It's up to manufacturers and companies like us to innovate and make sure that these products get more and more efficient and cost the same. So that's the challenge, the opportunity. And every challenge is an opportunity.
What you wanted to do was make these motors, the BLDC motors, as a way to reduce energy inefficiency.
So we make the controllers for this. When we looked at this industry, that was really the gap. India has a pretty good motor manufacturing ecosystem in place. And the motor manufacturers, while they were mostly making induction motors, have already been able to make that shift from induction to BLDC quite effectively. It was a massive concern whether the Indian motor manufacturing ecosystem would be able to catch up. But you know what? It's happened rather easily, in my opinion, compared to what people were expecting.
Who are the biggies in motor manufacturing?
So, of course, different applications have different players. So in the home appliance space, there's a company called PICL, which makes motors for air conditioning, outdoor units and indoor units. There's a company called SEPL, again, Swaminathan Enterprises. And of course, you have the fan companies. The fan companies make 40 million motors a year in India. And they're all the Cromptons of the world, the Havells of the world. And interestingly, a company that I have so much admiration for, this conglomerate called Yash Fans. I think they might make around 30% of the fans that are used there, maybe even more than that, used in India, just one company. And of course, they make and brand and sell, all of it.
They're a contract manufacturer.
Yeah, they're contract manufacturers, ODMs. Yeah. So these applications are extremely material in terms of our overall energy mix. So currently, 25% of domestic energy usage in India is from ceiling fans, and only about 13% is from air conditioning. But come 2030, with the forecasted penetration of air conditioners in Indian homes, that energy mix will move to a 30% energy consumption by air conditioning. And I think ceiling fans fall to around 15 or 16%. So as you can see, this is very significant. At this moment, that 25% of domestic energy consumption, residential energy consumption from ceiling fans is equal to 6% of India's total energy consumption. And that's a huge amount. So imagine if you were able to replace all the ceiling fans with BLDC ceiling fans, that 6% would become 3%. Imagine this is such a low cost and such a low friction way to save 3% of India's total energy consumption. And it's ridiculous. So there's that. And as the penetration of air conditioning increases, I think India has about an 8% residential air conditioning penetration. Of course, that depends on who you ask. It's between 5 to 8%. And this will be about 30% by 2030. So
yeah, growing incomes, like the first thing you do as your income increases, buy an AC.
Growing incomes, but also it's going to be a point where it's going to become imperative for human comfort for people to use air conditioning, especially in these extreme summers that we're already experiencing, and it's going to be getting considerably worse in the decades to come. So that's what we're going after.
So you said with co-founders, tell me about that. Like, why did you want to have co-founders?
My co-founders are also like the custodians of our technology. So they're the technology guys, right? I don't even pretend to be a technology guy anymore. The story of me and my co-founders is a pretty interesting one as well. When I was a part of the previous company that I worked with, I was exploring range expansions, product expansions as much as I could. So looking for opportunities in other industries. And at the time, I met with my co-founders who had started a company called TCTL, Think Circuit Technologies at the time. And they were doing some work for the Indian Railways and for defense like BEL, etc. I, in my personal capacity, invested some amount in that company and also jointly invested in the development of a technology for the Indian Railways. So we worked really hard on trying to develop what was called a CCB, computer controlled braking system. But we were successful in creating the technology, but I would say very unsuccessful in navigating what it takes to do business in the Indian Railways. It's so ridiculous that the way it works is there's an organization called the RDSO, which uploads specifications for a particular product. And once the specification is uploaded, you can develop and bid for that particular project. So for this particular project, it was called the Indigenous Computer Controlled Braking System. They had created the entry on their website, but didn't upload the specifications for over 4 years. It was just a waste. Eventually, after having worked with these guys for a long time and after having invested a fair amount of money in this project, it was ultimately a failure. And you would think that at that point, people wouldn't want to see each other again or have anything to do with each other. But I kept in touch with these guys because I believed that they were great technology partners to have. And after I exited Solid State Systems, that's my previous company, reached out to them and we set up Virtual Forest. And Virtual Forest then absorbed Think Circuit Technologies, which was their company.
So, what was the segment that you wanted to make these controllers for? Was it for fans or like what kind of?
Okay, so I'll start off by first of all describing the story behind the name of our company. So our company is called Virtual Forest Private Limited. Just like how trees sequester carbon emissions from the atmosphere, our products mitigate carbon emissions from entering the atmosphere. It's our objective to get as many of our products out there. It's equal to planting trees and hence and making a virtual forest. So that's why we're called Virtual Forest. Now, our objective is we create motor control solutions for the journey to net zero. And we've identified a couple of technology pathways to help reach that. The first one is energy efficiency. And we started doing work in energy efficiency and specifically in home appliances because this was a segment that had an existing market at the time. We identified air conditioning as the first place that we would do work. And the reason for this was because when we started 3 years ago, inverter air conditioners already made up around 50% of the overall annual sales. So there was an existing market and the opportunity to start generating revenue as early as possible, although it did take longer than expected. And that's where we started work. Of course, the downside of that is you seek an import substitution opportunity, which means that you're operating in a space that already has a lot of competition. But that's where we started. And from there, we've gone on to create solutions for BLDC ceiling fans. And both of these products are now in mass manufacturing. And from Q4 of last year up to now, we've been supplying several 100,000 pieces of these into the market. And so now this business has started growing at a good rate. The good thing is that after having established a bit of a track record, after having had a success in this particular segment, we're really starting to see network effects now. So First of all, we are getting a lot of repeat business from our existing customers for other appliance requirements. But also, you're slowly gaining some kind of leadership position as far as motor control is concerned at the moment. And we get a lot of adjacent projects as well in other applications. And now in customer validation, we have a couple of key new products which will be entering production this year as well. So we have a solution for solar pumping, which again is a huge application for emissions reduction, and also we have a product for inverter washing machines, which will go into production this year, and also other small home appliances like mixer grinders and stuff like that. So all of these are BLDC motor controllers for these applications. So they make them much more efficient, but also add a whole lot of new functionality and reliability to these applications. So that's one of the major technology pathways.
Pre-virtual forests, the controllers were being imported from China.
Yeah, 100%. They still are to the vast majority of controllers are still imported. And that's another major theme, is the fact that we're really trying to make sure that certain applications like air conditioning, where there's going to be so much aggregated demand over the next decade or so, it's important to make sure as much of the value addition for this demand which is generated in our country stays within our borders. And so that's a major objective for us as well. And that's why we're trying to really help substitute products which were otherwise wholly imported from China and other countries. So that's how it is. So the technology pathway of energy efficiency is something we need to do work in. While we're doing a lot of work in home appliances right now, we will also be focusing on industrial applications in the latter half of this decade. We are already doing some minor projects for certain niche applications, but we think industrial use cases will be big for our energy efficiency technology pathway. I'll give you a description of the kind of niche areas that we're already starting to do some work. So there's a company that makes coolants for coolant pumps for CNC machines. So currently they have 5 or 6 different models of pumps which have different flow rates and work for different sort of coolants. By using our technology, by using our controllers, they're able to standardize one pump, which is much smaller than all the different pumps that they have right now. And they can control the speed of that pump, the flow rate, the sort of torque required using our controllers. That's a big sort of advantage for them. That's the example of some of the industrial applications that we'd be going after. And we go from there and we see what else we can do. The second technology pathway is e-mobility. That's a segment that we started doing work in I'm going to say about August of 2021. We started engaging with OEMs as well as tier 1 companies in this particular space. And since then, we have, first of all, understood the requirements of this, done a whole lot of R&D in the various sort of controllers that are relevant for our market at this juncture, and have developed products towards this end. Currently in validation, we have a controller for low-speed two-wheelers, which will be going into production in the next quarter. But very recently, we've won 2 extremely prestigious projects in this segment. The first of them is to develop the global platform for NXP, which is the largest automotive semiconductor manufacturer in the world, and Arrow Electronics. So Arrow and NXP have joined hands and contracted us to develop a controller, which will now be their global platform for this particular application. This will be for high-speed two-wheeler and light logistics application. We will own the IP, but they will have distribution exclusivity for a period of 3 years. So this is great. They've recognized our capability and are investing in this development.
Well, what does Arrow do?
Arrow is the world's largest distributor of semiconductors, Arrow Electronics, yeah. The second project that we've recently won is something that we're extremely proud of. There's an organization called GITA, Global Innovation and Technology Alliance. This is a joint venture between the Department of Science and Technology and CII, the Chamber of Indian Industry. So they partner with organizations, scientific organizations in other countries, in our case with Israel, with the Israeli Innovation Authority. So the objective here is to facilitate collaboration between companies from both countries to create products which can go into commercial production. About 8 months ago, we participated in this grant funding program where we presented a project plan. Us along with a partner in Israel from the motor domain space as well. And we presented our project, and we've been through extremely in-depth audit process by IISc, by IIT Mumbai, where they visited us and done several audits of our technical capability of the actual technology and the project that we're proposing. And we've also had several commercial audits by certain organizations to see how feasible our plans are and whether everything is in order. And in June of this year, we were awarded the grant. Us and Redler were awarded the grant to develop what will be the next generation in powertrain motor controllers for light electric vehicles. We will specifically be working on medium logistics requirements to begin with, but this will be a game changer. And these products are going to be ASIL certified. That's the Automotive Safety Integrity Level. These are global safety certifications, and that's something that we will be putting in place with this controller too. And this is a 24-month R&D project. And being a startup, it's pretty rare for us to be awarded a grant by the conservative Indian government, but it's a great validation of our R&D capability and our overall project strength. And we were awarded the full project budget, the maximum project budget that they assigned. We were assigned a budget of $4 million to complete the development of this project. And the final sort of technology pathway that we hope to do work in is carbon capture. So I believe that motor control will play a very big role in applications like direct air capture, large scale air purification. I think Delhi already has a couple of air purification towers and things like that. These are going to be more prevalent, and we believe that motor control will play a big role here, and that's something that we're tracking very closely. So the technology pathways that we've identified, the decarbonization pathways that we've identified, that's energy efficiency, the electrification of mobility, and finally carbon capture. These are the paths to net zero, and that's where we're trying to play a part. It's technology, climate change is certainly the biggest technology driver, and this is how we believe we can make a material difference.
I have questions about some of the stuff you said, but I want to start more like at the origin point of it. How did you get a plant up and running? Did you have enough funds from the sale of the last business to set that up? Or
so we don't have a plant. We don't manufacture anything. We're an R&D company.
You said you're supplying about 100,000 controllers.
So we work with contract manufacturers as well. So one thing India has is a reasonably well-developed MES ecosystem. That's electronic manufacturing services. And what is lacking in the Indian ecosystem is design capability. So Indian companies are essentially assembly houses for designs which are provided by others. And this ecosystem is in place. Of course, it needs to grow significantly, but it is. And we play the role of a design partner. We create these technologies and we get them manufactured by third parties and supply to the end customers. Now, I'm making it sound sequential, and that's how it's not that smooth. When we started this company, we very naively thought that that's how it works, that you go to an end customer, you say, I have a design, and then they take it from there. It's not like that at all. So basically, while we don't manufacture in our own plants, we have to play a role through the entire process. I would say certainly in the appliance segment to some extent, and okay, that's not true. There's a full range of companies with various R&D capabilities, some of them extremely well developed, where they provide a very well designed requirement and have everything in place to approve a product, to test and approve a product. You have some companies that will have a competitor's product. They'll place their product next to it and say, okay, I press this on the remote, I press this, it has to do the same thing. You have companies like that. And then you have some companies that will say, oh, my competitor has a product. You go buy it from the shop and then you create something for me like that. So that's the kind of range of companies that you have to deal with. So we had to very early on create a business model that would serve this ecosystem. And that meant, first of all, hand-holding companies in the absence of a design, a requirement document, walking them through the integration, through the design process, and finally taking the products to manufacture.
So essentially, you are charging them for design services.
Yeah, for design services, essentially, yeah.
Okay, so that's like a design agency contract in a way.
Yeah, that's right. Now, another customer who we had to work with them from literally, like I said, going to the shop, buying a product, bringing it to their office and that level and defining everything, doing the costing for them, but we also manufacture and supply the finished product to them. So that is...
So then it's like a part you're charging them, like whatever X rupees per controller, and in that X rupee per controller, some part you're paying to your manufacturing partner and some part you're keeping as your monetization.
Yeah, that's right. Yeah, we buy a product from our partner, mark it up, and then sell to end consumers. That's one way that we do it. But also, when we started off this model, we work on two models with our manufacturing partners. The first one is a pure license fee model, where the EMS is the registered vendor with the end customer. So they supply the product to the end customer, and we get a license fee for product that's supplied. Now, when we started this company, that was beneficial because we didn't take the entire working capital load into our books. Our balance sheet certainly wasn't strong enough for that at the time. And as we move forward from there, we are now also doing some portion of our turnover in the product sales model. That is where we buy the product from the customer, EMS, add our markup, and sell to the end customer. The challenge there is that the entire working capital cycle is now your responsibility, which has its own challenges. There's a slight margin improvement in this model, but jury's out on which one's better. Of course, the other thing is that in the case of the product sales model, the entire sales value is a part of your top line. Whereas in the licensing model, it's just the license fee. So we track, in order to combat that, we track a metric called GMV. That's the gross manufacturing value. That's the total value of products manufactured using our designs. And we think that's a fair measure of our success as a company. And that's a metric that we're tracking, and we're doing very well. In our first year of production, which was last year, where we manufactured only in 1/4 of last year, we did a GMV of 4.5 million, and already Q1, we've surpassed that by some quantity. In Q2, it's been good as well. So it's our objective. It might sound a little bit crazy, but it's our objective that by 26, 27, we want to do a GMV of around 425 million. And we believe that this is eminently possible because, first of all, growth with our existing customers, growth with our existing applications, but also the huge expansion of the new applications that we're doing work in, like EVs, and certainly air conditioning and other segments like that. So that's how we're seeing this business.
Okay, I understood this part of it. I guess the only comment I have is probably the product sale model is more scalable, though you would need to raise external funding to scale it up. Because in product sale model, you have the optionality to tomorrow take the manufacturing in-house and improve margins even further and so on and so forth.
Look, yeah, but let's just say that there is no differentiated capability required to manufacture the products at this juncture. However, if there is some specialized manufacturing capability required, then it would make sense for us and to do this in-house. But at the moment, it's not a part of our plan. Also, I've worked in manufacturing for so long. I'm so done with that industry.
Okay, I understand.
Okay, I'm only half joking. But also, there isn't, in just pure play EMS as it stands right now, I just don't think there's enough margin available to really justify getting into manufacturing specifically for these products.
Have you raised funds so far?
Yes, we've had in July 2020, before when we were pre-revenue and pre-product, we raised a pre-Series A round where a company called Napino Auto and Electronics took a strategic stake in Virtual Forest, a small strategic stake in Virtual Forest. And they continue to be one of our, I would say, our key manufacturing partners as well. So it's worked out in that way.
And this is like an Indian manufacturing company, Napino.
Yeah. One of India's premier automotive EMS companies, mainly serving two-wheeler domain.
Now, coming to the EV part of the business, right now, I guess EV would be a small contributor. That's more like a future-looking thing.
Yeah, at this juncture, certainly, it's a smaller, we're pre-mass production for EV still. We're still in the customer validation stage. That'll happen in the last quarter of this year. So it's likely to be a small portion of our turnover this year. However, moving forward, we hope that it's, as per our forecasts, come 26, 27, about 40% of our business will be air conditioning, 40% will be EV, and the rest of the applications will very likely make up the rest. Although having said that, I think that in our forecasts, we've probably not been very accurate with the potential that washing machine controllers have. And that's something that might end up being a much larger part of our product mix.
So in the EV value chain, they buy the controller from you directly, or they buy a motor controller unit together from the motor company, the motor manufacturer?
So I'm finding now that while a lot of our initial interactions were happening with OEMs, we're finding now that most of our work is with tier ones. motor manufacturers, because it's certainly a situation where the motor and controller would have to be properly integrated and sold as a solution to the end customer. I'm finding that's becoming the more common model. Although we have had conversations with OEMs directly and then they source the motor from somewhere else, but eventually that relationship between the motor manufacturer and the controller becomes sacrosanct.
Okay. So your customers for the EV business would be the motor manufacturing company, but these are not yet manufactured.
In some cases, our conversations are directly with the OEM as well.
But are there EV motor manufacturers in India, or do they all get imported?
A significant number of motor manufacturers in India.
Okay. What are some of the names there that do?
So the big players, of course, are Sona Comstar. There's even the company that has participated in our initial funding round. The Pino is a manufacturer of EV motors. There's, of course, in Bangalore, you have a company called SEG, which is ex-Bosch Motors, now manufactures a large quantity. Famously for Ola, they manufacture the motors. And there are a million small companies out there that are manufacturing motors. Literally as many motor manufacturers as they are two-wheeler EV manufacturers out there.
In the long term, I'm guessing your customer base will be these motor manufacturers, right? Because for an EV company, it's a lot easier to buy an integrated unit than to buy from two separate places, like the motor separately and the controller separately.
Possibly, but some of the OEMs which have a well-developed understanding of the electronics would want ownership of the technology, or in some cases be involved in the controller, certainly controller approval, but also the software are part of that. Because there's a huge amount of integration between the controller and the panel as well. So the display, that's also something that has to be considered.
Your controller versus the controller of let's say a legacy player for an EV motor, what would be the performance difference between them?
Right now, our competition is Chinese imports. There is nothing else happening. There are one or two companies. There's one major company, which is a Chinese company, which is assembling in India. There's a huge way to go as far as performance of electric vehicles are concerned. They are particularly low performance at the moment. So first of all, to begin with, our controllers put in place certain performance algorithms that we find much better, specifically for small things like starting on an incline and a smooth ramp up and a much quicker ramp up in speed and stuff like that. That's particularly poor, especially in the lower speed EVs that are out here in the market already.
Do the controllers have a chip? If you're putting an algorithm, are these like chip controlled?
Yeah, absolutely. So these controllers are essentially a microprocessor that has a motor control algorithm. That's the firmware. An application layer sits on top of that, which then controls all the peripherals of the bike. And we're able to basically modulate the power that's convert a human interaction like turning the accelerator. That has to somehow be converted into motion in the motor, and that's done by the motor controller. The motor controller draws power from the battery, modulates it, and then the pulses are given to the motor to operate in that way. The motor controller also has to take into all the other various things: the brake being pressed, is the ignition on, is the kickstand down. All of those signals have to be integrated into the controller, and the controller then manages the overall motion of the bike.
Fair amount of data going into the controller.
Yeah, fair amount of signal going into the controller, yeah.
Which is why like a more sophisticated manufacturer would want a deeper control, because to engineer all the signals and like to engineer the performance also, the controller would play in.
Absolutely, because the performance of the bike, assuming it's not an absolutely underpowered motor and all of that stuff, is largely controlled by the controller performance, and that's a key part of the overall piece.
What you are doing better than the Chinese imports is that your algorithms are more finely tuned for these niche use cases, these specific use cases.
We believe that's a major part of it. But apart from that, it's the integration with the motor plays a very big part in it, and that we have particularly developed expertise in that area. And just in general, the hardware design, the performances of the overall hardware is also, it's when we say Chinese imports, again, there's a myriad of companies out there. And you have low-cost players which make low-cost products, and you have bigger players who are making world-class competitive products as well. So that has to be kept in mind.
Is there a way for you to train your algorithm? Can you get like data about what's happening, does that data come to you also? Like the interaction between human input and converting it into that output, and whether that was desired, not desired, so that your algorithm can improve. How do you build a better algorithm?
Capturing usage data will definitely help. And that's something that we hope that we'll be able to get from the EV manufacturers. This is all being captured on at the display level and at the HMI level. And that, if it's shared with us, would always help us improve our performance algorithm. But the motor run algorithm itself is something which is designed at the design stage to create efficiencies and to make sure that the performance is good and low noise and stuff like that. So that's something that happens at design stage.
You would be working in a lab and you would be testing out multiple settings of the algorithm and tweak the algorithm and to constantly see which one is.
Yeah. There are a huge number of parameters which have to be considered, and that's something that's a constant part of the R&D process.
Does your R&D happen on a virtual motor, or does it happen on an actual motor?
So some of the design happens, like the algorithm design happens using MATLAB, and that's a simulated environment. But most of the work happens on actual physical setups.
And tell me about your org structure, like what kind of headcount do you have and so on?
So we currently have 32-person headcount, 5 co-founders, and all of us have really great complementary skills. First of all, our technology leadership is a part of our co-founding team, which is a huge advantage. Our CTO, Nazir, is of course the overall custodian of our technology, but also the key interface with clients and the EMS partners that we have. Ajanan heads the firmware and software function in our company, and Ravi heads hardware and motor control. He heads that functionality. We have a CEO, we have a COO, CFO, Sandeep, who joined our organization, I'm going to say about a year and a half ago now. He's also part of our co-founding team. Sandeep has a huge amount of experience in global organizations, having played very senior roles. He was the CFO of Dell EMC India, also the VP of Finance for HP India, and various other very senior roles. So he comes on board to really, I like to say, take us from being a pirate ship into a navy to help us really. We need to know how to build an organization that has hundreds and hundreds of people in our headcount. And that needs to happen in the right way. And Sandeep is on board to help us do that. And I'm CEO of Virtual Forest. And, I mostly work on strategy and partnerships and growth and things like that. And also making non-technical comments in technical meetings is something that I'm told I do quite a lot. So all of us have had some amount of entrepreneurial experience as well behind us. Me, probably a little bit more than my co-founders. And we all bring, I guess, a lot of lessons to the table and things that we're trying to get right in Virtual Forest. And the short time that we've been at it, we feel like we've been able to make a good run of things. There's this urban myth that, Francis Ford Coppola, when shooting Apocalypse Now, I'm probably showing my age a little bit, but like when shooting Apocalypse Now, he had this thing on a wall, this triangle that said good, fast, and cheap. And you could pick only 2. So if you want something that's fast and cheap, it's not going to be good. You want something that's cheap and good, it's not going to be fast. I found out many years later that he didn't really do this. It's just an urban myth. But in our case, I try, after learning lessons in my entrepreneurial career and my co-founders as well, our triangle is growth, survival, and indiscipline. You can't choose 2, you can't have all 3. So if you want growth and survival, you can't have indiscipline. If you want growth and indiscipline, you're not going to survive.
And that brings us to the end of this conversation. I want to ask you for a favor now. Did you like listening to this show? I'd love to hear your feedback about it. Do you have your own startup ideas? I'd love to hear them. Do you have questions for any of the guests that you heard about in this show? I'd love to get your questions and pass them on to the guests. Write to me at ad@thepodium.in. That's ad@thepodium.in.